It's important in biochemistry, especially when we're in the laboratory, that we're able to express amounts and concentrations of various molecules. So I just want to take a few minutes here and be sure that we understand moles and molarity and some of the calculations that are surrounding those things. So just recall that the term mole, sometimes abbreviated MOL, is really just a count, right? Like a dozen is 12 eggs. A mole of something is just this really big number, 6.02 times 10 to the 23rd number of particles. So a mole of eggs is just, a bit bigger than a dozen eggs, but it's just a number. That's all a mole is. And so when we're weighing out or measuring a particular molecule, we think about terms of what its molar mass is to help us understand essentially what mass of that molecule we need of that compound we need to weigh out. And so the molar mass then is essentially the amount of grams, the number of grams of material in 1 mole. So how much does 6.02 times 10 to the 23 carbon atoms weigh or water molecules weigh, right? That's what the molar mass tells us. And then the other important concept is concentration, and how we use molarity as sort of the center of the universe for concentration. And so this is a number of moles of a compound that's in a liter of solution. So the units of molarity are moles per liter. And then you might recall the C1 V1 equals C2 V2 equation as a way to make dilutions. And so I want to go through a few examples here of all of these things. So a couple things. First of all, this mole per liter is called molarity. We often just refer to it as a capital M for molar, right? Same as the capital M, mole per liter, but just notice that is different than a lowercase mol or mole. This is a count, an amount. Mole is an amount, whereas a molar is a concentration. So you might remember from your various other experiences in chemistry and maybe physics, if you've had that, the idea of dimensional analysis or factor label method. Hopefully you've developed some of those skills, and we're going to put them into play here. This is kind of my little slightly different approach to all that, but I think it works pretty well. So a lot of questions, not all of them, but a lot of them like this will have 3 elements or more, and you'll have to put those together. I refer to this as the have, want, link system. So that means we're going to have something, and we're asked to get something, or we want to have some other number, and then something's going to link those 2 numbers together, or maybe multiple things are going to link those 2 numbers together. And it's up to us to figure out how to put these pieces all together. So for question number 1 here, how many moles of sodium chloride are present in 61 grams of sodium chloride? And so the have in this case is that 68.1 grams. We have that many. The want, well, this is often where the question is going to be. How many moles, right? What's the question wording? How many moles? That is the want. So number of moles. And then what's the link? Well, the link is the thing that's going to link those 2 ideas together. We have grams. We want to get to moles. Well, what's going to link those together? Well, if we look at our math up here, notice up at the top, we've got this grams per mole right here, and we often refer to that as the molecular weight, right? Or molar mass, molecular weight, same sort of thing. So the thing that's going to link us here is the molar mass. So for a lot of these problems, I suggest starting by writing down the have. What do you have? Well, all right, we have 68.1 grams of sodium chloride. Now put that in parentheses, it's all by itself. Remember, the want is going to be on the right-hand side. So I'll say equals whatever our want is, some number. I'm not going to write a number, but it is going to be moles of sodium chloride. And so we're going to figure out that answer, but we need the link. The link is going to go in here. And it's going to be the molar mass, or the molecular weight of that sodium chloride. And how do we do this? Where do we put it in the numerator, the denominator? How does that work? Well, notice we want the units of grams to go away, and we want the units of moles to appear in our answer. So we need to cancel out grams. We need grams in the denominator, and we need then moles in the numerator. And so if you look carefully at this molar mass here, 58.4 grams per mole. So the 58.4 goes with the grams. So that goes in the denominator, and we've got 1 mole implied in the numerator. And so watch, if we then cancel out our grams with grams, we're left with moles up here in the numerator. And so the units are what we want, moles of sodium chloride. And so we can just go through and do the math, 68.1 divided by 58.4. And we'll discover, if you do a little bit of rounding, you get about 1.17 moles of sodium chloride. That actually should make some sense if we know that the molar mass is about 58.4. So that's how many grams are present in 1 mole. Well, we've got 68, so we've got a bit more than 1 mole, and yeah, about 17% more than a mole. So my recommendation is for all these math problems to apply a logic test. So that's kind of the last one, right? Can you think logically about the question? Does it make sense? And indeed, this one does. So 1.17 moles of sodium chloride. All right, next up, let's talk about concentration. What is the molarity of sodium chloride if that same amount, 68.1 grams, are added to a solution with a total volume of 250 mils? And so this is one where the have, want, link system might not be needed because we kind of have a formula. Because we know that a molar, by definition, is the mole per liter. How many moles are in a liter? And so here, we already know how many moles. We just calculated it in the previous problem. And we now have a volume in milliliters here. So we can do the following. We can say we've got 1.1, I'm actually going to add back a sig fig, 1.167 moles of sodium chloride, and we brought it up in a total volume of water of 250 milliliters. But I'm not going to write 250 here. I'm going to write 0.250 liters, right? Because I need this to be in moles per liter. If you need to put in another step, if you want to write this as milliliters and you put in another step that converts that milliliters to liters, an intermediate step, that's totally fine, whatever works for you. But notice now we've got moles per liter. We can just go through and do the math, and we would discover that we get about 4.67 molar sodium chloride, right? So that's a pretty high concentration, I suppose, of sodium chloride, almost 5 molar. All right, so again, that's the definition of molarity. It's a concentration, the amount, the moles of a substance in a liter. It's not simply the amount. It has to do with the total volume that stuff is in as well. And then last up, thinking about dilutions and how do we go from one solution to another. If we're diluting this certainly is very relevant for any of you who might work in a compounding pharmacy or something like that, or pharmacology is what you're interested in. So here we go, thinking about some of these things. So what's the final concentration of a solution if we take 100 mils of what we just made, and then we essentially add another 400 mils to get a final concentration of 500. I should say added 400 mils of water to get to a final total concentration of 500 mils. Well, this is a C1 V1 equals C2 V2 question, right? We are diluting. We're taking some material and adding water to it. So the answer is going to have a lower concentration, hopefully. So let's just go through, whenever it's these dilution problems, I think it's a good idea to understand what the C's and the B's are and label those. Right, so the left side of the equation is always the concentrated side. This is the original solution. And the right side of the equation is the diluted solution. So we have a volume right here of 100 milliliters. We're taking 100 milliliters of that. So this right here is the V1, okay? And the solution from number 2, that 4.67 molar, that is the concentration, right? That's C1. So, and then we are diluting that into a total of 500. So 500 is our V2, our final volume. And what we don't know, and what we're asked to find, is the final concentration. The final concentration, that is C2, right? So the way this ends up working out, I'll put these things into the equation the way it's written, and then we'll shift some things around. So I'm going to take C1, that's 4.67 moles per liter, or molar, same thing. And that is in a volume of 100 milliliters. But again, I'm going to immediately convert that into liters rather than milliliters, right? 0.1 liters is 100 milliliters. This equals C2, we don't know what that is, that's what we're going to solve for, times the final volume, V2. Again, I'm going to go ahead and convert that into liters directly. If you need to do a subsequent calculation, that's fine. So we're going to rearrange and solve for C2. So you're going to divide both sides by 0.5 essentially to get rid of this and multiply these two numbers together. If you do that, you will discover that you get a final answer of 0.934 molar sodium chloride. So that is your diluted solution. Again, let's apply a logic test. Notice that we went from 100 mils up to 500 mils. So we kind of like, it's like, 1/5 the concentration it should be, right? We diluted it by a factor of 5. And notice that we started off almost at 5 molar, and our final concentration is a little bit less than 1 molar, so a little bit less than 1/5. So again, apply a logic test to these questions at the end. Does it make sense? If I got an answer of like 30 molar here, we would have done some math wrong, right?